Hello everyone, welcome to today's daily Leetcode challenge. Today we'll be solving an easy question, question 905, sort array by parity. I'll be going through my thought process as I come up with a solution, then stick around for the end of the video where I compare my solution to the solution of others. With that, let's begin the question. We're given an integer array nums, move all even integers to the beginning of the array, move followed by all of the odd integers. So if a array would look like this, we would have all the even numbers here and all the odd numbers to the right. Pretty simple. We are given two examples. The first example is an array of 3, 1, 2, 4, and we can see that we have moved 3 here and 1 here, and yeah, they're switched totally 1 to 1. Cool. So how would you come up with a solution for this problem? Well, right away I think of um, probably finding a middle point. So let's say I have some numbers here. Let me do this actually. I'm going to be highlighting highlighting the even on even in red and odd in blue. Let's say I have something like this, where I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 overall integers. My first instinct is, hey, I need to find the middle of the array, right? Middle of the array where the integers are going to be split. Let me make this a bit bigger. Where the integers are going to be split into. So in my head, I right away go, well, I have 1, 2, 3, 4, 5 reds, and I have the rest 1, 2, 3, 4, 4. So basically find this middle point, right? And this middle point can be found extremely easily. I can say len of the input array nums, and then count odd, right, would be just like a for loop that iterates through that looks through all of these values here and counts all of the odd ones. Pretty simple. And then yes, and then I could and then what would I do? Count the number of odds. I know where the center is, and then I could maybe just go from the center, right? One arrow going this way, one pointer going this way, and I'm sure that I will have enough of these situations where I'm splitting up a blue with a red to get all of the things in the correct positions. Actually, if I was to draw this entirely correctly, without any mistakes, I would be looking at, I would be splitting up this right here. Right here, and I would be doing one split. No, I wouldn't be doing that. I would be doing this and this. I would have to switch them in order to get to this point, right? And that's all fine, right? I can do that. But what if there's a more faster way? I'm thinking that if we're going through like a middle out approach where we found the center where we know the split is going to happen, and we just go until maybe we reach one of these ends. But there's, I guess, a less intuitive approach, or could also be intuitive, where you essentially find this center by going from the left, the right, and the left. Just having 2 pointers. Let's say left. Let's have I equaling the left pointer and j equaling the right pointer, and we could do something like while I is less than, let me rewrite this, I is less than j, we would have some logic in here that maybe goes, the left pointer here goes one at a time. Oops, sorry, this is I, this is j. The left pointer goes until it finds something that interests it, and so goes the right pointer, right? One at a time until finds something that it interests, and then it makes the swap. And then once again goes here, finds it. This one would skip one, but then it would eventually find this one, do the flip, and when they meet here, the while loop would just exit, and we would have our solution. So yeah, I don't wanna probably get too deep into drawing this, but this is pretty simple. Let's try implementing it real quick. I said that I'm going to have both I and j, I pointing to the even. Did I say that? Yeah, red is going to be even. Red is even, blue is odd. J is just going to be len of nums minus 1, while I is less than j. This is that condition where the 2 pointers have to meet. I'm going to take 2 variables. Left is, what was that going to be? Left is even equals num I is modulo 2 equals 0, and then say right is odd nums j modulo 2 equals 1, and then simply just some logic that if not left is even and not right is odd, I'm going to make the swap, right? I'm going to say that nums I nums j is equal to nums j nums I. Then I will say that, what else do I have to look out for? If, well, this is a situation where they both do the swap, and so if I do the swap, I say I plus equals 2, j minus equals 1. Now, if only one of them is not true, like for example, if only the left one is, no, sorry. If not left even, so if not left is even, then I simply do j minus equals 1. So if not this is even, if not, wait, sorry, what did I say? How about I start looking for the opposite? I'm gonna explain why in a bit. Left is odd. I can do this. Left is odd. true. If left is odd and right is even, if left is odd and right is even, I'm going to make the switch. And then I would say I plus 1, j minus 1. If that's not the case, that means that one of them has to be false, right? If left is odd, that means that j must be uneven. L if. I also have another condition where the right is even, but left must be odd. So L if right is even. If the right is even, then the left must be odd. And so I do I plus equals 1, right? And finally, if both of them are false, I simply say I plus j minus 1 and return nums. Let's see if this works. Yeah, so the idea here is what? We have 4 scenarios. We have that both we have that both left pointer is odd and right pointer is even, in which case we do the split. Left is odd and right is even, in which case we do the split, and then iterate, move the left pointer up 1, move the right pointer down 1. If that's not the case, there's 3 more situations. We have that only the left is odd, and if only the left is odd, that must mean that the right must be, if the left is odd, the right must be, no, it must not be even. It's not necessarily even. Does this even work? Should. If the left is odd, shouldn't I be, I'm aiming to get the, okay, 1 second. If left is odd, then why am I allowed to just move the right pointer once? Shouldn't it be more like this and not right is even and not left is odd? Would this work? I mean, this is how it's supposed to be, I think. Yeah. Why did that previous one work? Interesting. Anyway, yeah, I think this is a pretty quick solution, and yeah, I mean this one is just less code, so I would recommend this one initially. If left is odd though, why does this? If left is odd, this doesn't necessarily mean that right has to be. Oh, it works because I see why it works. It works because I would have essentially done the right step. I would have decremented the right pointer by 1 anyway if left is odd. So if left is odd, then I'm either doing it here sorry, I'm either doing it here, here, or here. I see. Okay, so that's why it worked, but I don't actually like this. I think a better approach would be to kind of separate what is happening into maybe even just three legs, because we're repeating this multiple times. So why not just have a situation where if if we are sure that they're both in the condition where they need to be switched, then we switch them. Um, and then we're doing I plus 1 and j minus 1 anyway. Why not say that L if left is odd and right is even? Oops. Left is odd, and right is, oh my god, is even. Then say, no, sorry. Right is even. If right is not even, then I minus 1, else j plus 1. And there we go. And now we only have 3 legs, and this should also work. Yeah. And it's a bit faster. Anyway, yeah, I think this is cleaner because we're not doing the I's and the J's on every step. But cool. Yeah, thanks for watching this. Keep this one quick. Stick around for another video tomorrow. Bye.